Hey friends, I want to thank our sponsor, Raygun. Are you struggling to replicate the bugs and performance issues that your customers are reporting? Plug Raygun into your web and mobile applications right now and diagnose problems in minutes rather than hours. Kiss goodbye having to dig through log files and relying on frustrated users to report issues. Make your software development life so much easier using Raygun's error, crash, and performance monitoring tools. Every software team can create flawless software experiences for their customers with Raygun. Try it free today at raygun.com. That's RAYGUN.com. Hi, this is Scott Hansel, and this is another episode of Hansel Minutes. And today I'm talking with Tom Spilman from Sickhead Games, who also is one of the leads on Monogame. How are you, sir?
Hey, Scott. How you doing?
I'm pretty thrilled to be talking to you because I like playing games and then discovering after I've beat it that it was written in C# or .NET. You know, it's kind of like something that I feel far away from, which is games because I've never made one, and then something that I'm very close to, like .NET and open source. And then I'm like, oh, I just played that, and that was it. That was in .NET and built with Monogame. That's so nice.
Yeah, it's pretty incredible. We're always really. It's always really neat for us to hear about games that have shipped, and it's like, oh, that was written in Monogame. Like sometimes we don't even know when it happens.
Really? They don't have you don't have to phone home and let you know?
Yeah, no, it's open source. You know, anybody can do anything. So it's kind of sometimes we find out ahead of time. Sometimes we find out after the fact.
Mm-hmm. And how long has Monogame been around, and what's the relationship? Because there was a thing called X&A Touch like 10 years ago.
Right. Yeah. It was originally called X&A Touch. It was written by Jose Ferraz, and he started it basically because he really liked the X&A API. You know, the original X&A guys, they wrote a really nice API to do C# games that, you know, a lot of people loved at the time, but it was kind of misunderstood, I think, at the time. But the API was really solid. It was built off of, you know, DX11 and DX9 concepts. So it was a really nice API to use to quickly prototype games and develop interesting games from it. And it was pretty powerful. And he liked it a lot. He was like, I'd love to have this on iOS, where the story at the time was not as good for building games. So he said, well, Mono's available on iOS. How can I make an API that looks like X&A but runs on iOS? And that's how he started X&A Touch. So he kind of originally built it from Bill Rice had a tool, a library called Silver Sprite, which was basically a version of X&A that ran in Silverlight back in the day. And he took bits of that and bits of another project called Mono X&A at the time. Then he kind of smashed them together and started working on it and got a version that worked on iOS. And that was the first version of Monogame that was available on iOS back in 2009. So it's been around for a while now.
Yeah, and when I look at the, go up to github.com/monogame, I'm looking at the list of supported platforms, and it's not just Windows, Linux, and Mac. It's Android, it's iPad, it's PlayStation 4, PlayStation Vita, Xbox One in 2 different formats, and my favorite console, the Nintendo Switch, as well as other things like tvOS. Is it hard to add a platform? Like, is it a big deal? Are there a lot of abstractions?
It depends on the platform. You know, the PC ones have always been easy because they're usually, you know, it's usually some form of OpenGL or some form of DirectX, and we're good to go kind of thing. Except, you know, when Microsoft throws a wrench in the works and gives us a new platform like Windows 8, where things were very different, right? So those are pretty easy. The phones are usually pretty straightforward because there's not a lot of new phones at this point. The consoles are the ones that are a little trickier, but we've kind of developed a technique over the years to get them to console that, you know, through a cross-compiler technology that we built that actually makes it pretty easy. Like our first one was, the first console we got on was PlayStation 4, and that took us some time to get that up and running. And at the time, we were using a version of Mono on PlayStation 4. And then Vita was the next one we did, but Mono wasn't available. So that's where we developed our cross-compiler to get there. And that took a couple of years to get that solid and reliable. But then after that, we brought it pretty quickly to Xbox One. And then after that, we brought it to Switch most recently. And that, I think from the day that we got a Switch dev kit to the day that we had it first have a game running on there, it was maybe like a month and a half or so. And then ever since then, you know, new ports are pretty quick. We've gotten pretty good at getting it to new console platforms, mostly because our cross-compiler technology.
So when you say cross-compiler technology, when I think about .NET, I think about a jitter, a just-in-time compiler. I think about a runtime, and then I always wonder, how would this runtime live or exist on a small system? And I understand that with Xamarin and on iPhones and stuff, you're doing basically ahead of time AOT, not JIT, right? Is the same thing the case on a PlayStation?
Yes, in a way. And the PlayStation 4, the current PlayStation 4 games, most of them are running using mono AOT'd. On the newer platforms, we've moved over to a cross compiler where we actually take C# code, we compile it as a C# assembly, then we run it through our cross compiler, which takes that C# code or a C# IL and dumps out a bunch of C++ code, tons of it, and then we compile that. Yeah, basically, actually like text. Yep. We compile that along with a custom backend runtime built from the Mono BCL and our own runtime implementation, kind of focused on game stuff. So it kind of omits all the security layer stuff that would be in normal Mono runtimes. And our own version of a garbage collector, and compile that all together, and we have a native assembly that can basically run on a console. And that's been pretty successful for us. We mostly went that direction because at the time, it's amazing how much C#, the ecosystem, has changed in the last 5 years. When we first started doing that 5 years ago, Mono was still a GPL product, and it was still owned by Xamarin. And if you wanted to use it on a closed platform, you had to pay a licensing fee. And that was kind of a problem a lot of times when we were trying to get to new platforms. It was like, it became a thing between Xamarin and the licensing in the console manufacturer to figure out a licensing deal, and that became, difficult. So one day, out of the blue, we were kind of just like, I think what it reminded me of is that the year that we did this, there was a demo of Unreal Engine running in a browser using JavaScript, that was using that ASM.js technology. And it was really impressive. And I saw that demo and it's like, if they can convert, cross-compile C++ to JavaScript and make it run fast, I can surely cross-compile C# IL down to C++ and make it run fast. So that's when we started that project. And, it took us quite a few years to get it to that point. But at this point, we have a pretty solid technology that we can deploy .NET applications or .NET games in particular onto consoles pretty quickly and pretty reliably. But it took quite a while to get there. And it's that flexibility that's allowed us to get to more consoles at this point. Now, Microsoft started their own cross-compiler tech. I think it's called Core RT. That's currently open source. And we've looked at that a couple times, but, ours has a few features that I think were better for us at the moment. But this is not something new. Like Unity does this as well. They have their IL to CPP technology that they built on their end. That's how Unity runs on most of the consoles nowadays. So it's kind of come into fashion, I guess, using a cross-compiler to bring .NET to other platforms. But I'm hoping one day, .NET makes all obsolete, with making a really core version of .NET that's fully open source and that's easily portable to new platforms.
Right, exactly. Something that you could go and call configure and make on, and it would just work.
Exactly. And that's always been very difficult. I mean, Mono's tried to do that. It's just Mono's a very complex beast, and it's hard to kind of do that kind of thing with it. And you have to have a lot of knowledge about the inner workings of Mono and how it builds in order to make that successful. And at the time, there was also a licensing issue. Well, the licensing issue went away a couple of years ago, right? So at this point, it's really only a matter of understanding the build system properly. But we've kind of stuck with our cross-compiler because we kind of get some things for free. We instead of breakpoint anywhere in the code and it works, I can set a breakpoint in the garbage collector and know when the garbage collector is running and why, or what allocations are having. So some nice features of doing that. But it also gave us a really good idea of how much .NET brings to you. The amount of code that you have to generate to implement even the most basic C# features is kind of incredible how much code is behind the hood to make that work. And it's focused our mind on how much better C# is for development than anything else. The C++ here is just a means to an end. The C# part is the part that we want to keep, and we're hoping that as .NET moves forward, that we're able to do more of that stuff using the common .NET that everybody else is using, and not our custom AOT process.
Okay, so speaking of bringing things to the table and hiding things, you're cross-compiling or transpiling from one language into another, and then there's a runtime. I mean, there's always the C runtime and things like that.
Right.
What do you do when the abstraction leaks? you said you can set a breakpoint. How is that possible that you can set a breakpoint in C#? Do you map from what's happening in C++ to what your intentions were in C#?
Oh no, yeah, no misunderstanding. We don't set a breakpoint in C#. We have some code in there that like emits line pragmas, so you can actually do that and see the actual C# code and do it that way. But we really often don't do it. We usually work directly from the C++ if we have to do that. But it's really kind of a throwaway. The idea is it's really treated as an AOT process. You run the cross compiler, it dumps out C++ code, updating source files as it needs to, so that it makes your build times minimal. And then when you build, it just builds the files that changed, runs on the device, and you can set breakpoints in the C++ code or at the low-level runtime code if you need to, in order to debug things as needed. But yeah, it isn't as nice as just working in plain C#. That's where we want to get to eventually, but that's going to probably require some more work on the official C# on getting it to be more portable, more easily portable to new platforms, which is still kind of tricky.
I see. So you want if you want to think about C++ as a minified C# in this sense, the way that we see source maps, and like I can do TypeScript or I can do even WASM or Blazor, hit F12 in the browser and then hit a breakpoint, and it's kind of a virtual breakpoint.
Right. Yeah, exactly. And I think, the web Blazor is another example of that kind of thing. Like .NET's really going everywhere at this point. And, I know that we were experimenting with more web-based C#, and it's very exciting for us to see Monogame running on browsers now with technologies like that.
Mm-hmm. Okay, so this is a game framework, but how much does Monogame give me? If I'm going to make a game like I'm looking at a game here called Chasm that's like a 2D, little dude runs around back and forth on a pixel screen. How much of this is a game maker and how much of this is just get a framework to help me blit things onto the screen? I'm trying to understand what it gives me and then what it doesn't give me.
Right. Yeah. I mean, I think that's a clear distinction that we can make there. Something like Unity, that's more of a game maker in that it's more of an IDE and more of a tool that you can more pull things together, drag and drop it, use pre-existing components and kind of build something more visually, I guess, in a way. Whereas Monogame is more of a programmer's toolkit than anything else. It is more low level. It's not really for an artist, even though we've had people that I've talked to, like a popular game, Salt and Sanctuary, that was really popular there on PS4 and lots of platforms here recently. That developer didn't really consider himself a programmer when he started the project. He kind of just looked at XNA samples and pulled together code and kind of learned as he went along, but he was able to build this really popular game out of it. Well, we're really a programmer's kind of level tool. So a lot of people come into it expecting something more Unity-like. It's not really that. It is really, if you want to really know your code from bottom up, this gives you that ability. If you want to write your own entity systems and high-level game systems and your own editors, that's really what this is about. It is not about here's an editor, here's a pre-baked system for rendering my game objects. It's really more about abstracting the low-level graphics and sound APIs and input APIs so that you can focus on your game code and your gameplay and not on, well, how do I make this render the same way on an iPad and the same way on a console?
Okay. So an example, like if we're talking about 2D games, because I just ended up finishing Katana Zero yesterday, and I'm doing a lot of 2D sprites. Thinking about sprites or batches of sprites, I just want them on the screen, whether I want them rotated a certain way or blended with other sprites. Monogame would hide all that for me.
Right. I mean, the Monogame has, again, coming from XNA, we kind of adopted the entire XNA API, which was really great and very friendly. And it had a concept of sprite batch where you would just say, hey, we're going to batch of sprites. And you can say, draw this one here, draw that one there, draw this one here. You just pass it a texture and a coordinate, and if you want rotation and things like that, and then you say end, and it takes care of under the hood to sort them, batch them, and render them to the screen. So it's kind of like a high level of that level. But you can also go down and actually work with vertex buffers and index buffers and shaders. And so you can go lower level if you want to, but the sprite batch is kind of a nice, convenient way to kind of get in there and do 2D things. And there's we have some 3D support where there's some model classes and things like that where you can bring in a model, import it in from 3ds Max, exporting as like an FBX or a Collada file, and then build it in the content pipeline and actually render render to the screen, but that's a little bit more involved. We see typically more 2D games, people doing more 2D games with Monogame, but there are also some 3D games out there. There's right now, one of the most popular or the most popular flight sim on iOS is called Infinite Flight, and that's all Monogame. And they took it and modified it and made some changes to make it fit what their needs are, since it's an open source project, but it is a Monogame based project.
Yeah, indeed. I actually had Laura Laban on the show in episode number 593 in August of 2017. And I'll make sure to put a link to her in the show notes. And that's, like you said, that you're seeing more 2D games, but Infinite Flight really pushes 3D. It's quite an amazing thing. I mean, you're looking at it. It's almost like a PC quality flight simulator in 3D on an iPad. It's nuts.
Yeah. They've done some really cool stuff with it. The quality there is really high end, and it's amazing that whenever we see these things, it's like, wow, that's Monogame as well. That's impressive. But it's really the time that they spend engineering their own systems on top of Monogame that's the real magic here. And we mostly see 2D games because in general, 2D games are much easier to develop and understand. From building systems and things like that. It's harder to get to a 3D game, but we have some 3D games that are out there. So we have a little bit of both.
Hey, did you know about the Strange Loop Conference? It brings together over 2,000 software developers for an educational and inspiring experience. You can see talks like monitoring traffic in space, behind the scenes of the New York Times crossword, securing cloud applications, building an open-source pancreas, the science and history of color, voice-driven development, probabilistic programming, the computers of Voyager, and Grammy-nominated recording artist Imogene Heap. Strange Loop 2019 takes place September 12th through the 14th in St. Louis. Get your tickets now at thestrangeloop.com and use discount code HANSEL, HANSEL, for $75 off. Now, you mentioned different shaders and low-level things, but it's low-level but still abstracted away from the hardware. Is that correct?
Yes. For shaders, for the most part, I guess the industry's kind of adopted HLSL as kind of like a basic standard for shaders. So like in Monogame, you build your shaders in HLSL, which is Microsoft's shading language that was used in DirectX. And we use another kind of cross compiler technology to convert that HLSL into GLSL for GL platforms. It's an open source tool. I forgot the name of it off the top of my head, that's used to do that conversion. And then on consoles, they're all kind of a little different. Some consoles use something very similar to HLSL, so we use that. Some of them already have cross compilers from HLSL to the console's native shader language. And, for the most part, that's kind of been adopted across the industry. Like even Unreal Engine, you kind of write your shaders in once, and HLSL, and under the hood, they cross-compile it to the right platforms, just because it's easier to do it that way than to try to write a native shader in that native platform's language. So,
and for folks who might not know that acronym, of course, it's high-level shader language, and then GLSL is the OpenGL shader or shading language. What is a shader? There's pixel shaders, there's geometry shaders, all flavors of shaders.
Yes.
What is a shader?
Well, I mean, a shader you can think of as a small program that runs on the graphics card. People don't realize that your graphics card is a separate PC, basically running separately from your regular PC. So your regular PC sends that graphics card some commands, and it runs its own programs. So every pixel that you see on the screen, or really groups of pixels, are run through a pixel shader that actually does all the mathematical calculations to build the final pixel onto the screen. And that's what you're building, is you're building a shader that just tells the GPU how to shade your pixel to colorize that pixel. And it can be everything from something very simple that just reads your pixel from a texture that you pass to the graphics card, or it could be something very complex that does some mathematical calculations and builds something very procedural. So it just depends. And there's, pixel shaders work on your pixels. Your vertex shaders work on the vertex data, on the geometry that you pass to the hardware. Those are kind of the basic building blocks of almost all rendering across all games and all game engines.
When I've seen 2D pixel games, or kind of this resurgence that we've seen in the last 5 or 10 years of 16-bit games, we'll call them, kind of a game like Chasm, or a game that could, like Stardew Valley, that looks like it could be a Super Nintendo game. they feel like we remember those games were, but they're far more sophisticated.
Oh, absolutely.
Like the little pixelated person will walk by a fire, and the fire itself casts light and changes the pixels, and that just wouldn't have been possible with simple sprites back in the day.
Right, absolutely. I mean, it's funny. We spend a lot of developers now spend a lot of time trying to get pixel perfect. Right, it's easy to be just slap an image onto the GPU and get some photorealistic looking image working. To get something pixel perfect where it looks like an honest to goodness 16-bit game from back in the day or an 8-bit game back in the day is very difficult to do properly. So I know that the Chasm guys, when we worked with them, they were very intense about making sure that everything was pixel perfect, that the art was exactly, all the pixels were perfectly square. There wasn't any cut off or, any small little differences in pixels, which is very easy to happen when you're trying to port it to multiple platforms. So it's an art and a challenge to make those things look like that, even though it seems like it's easy. It's actually not, and you see games like Chasm like that. You see Celeste, which was it was like Game of the Year last year, that tries to maintain that pixel perfect look, but also adds in new things like they all their UIs were kind of done in a high fidelity kind of look, mostly for portability and localization, but it had a very interesting look. So it's like people are mixing techniques, pixel perfect along with things that are more modern in order to build kind of, I guess, retro games that are different. They feel retro and they have some retro concepts, but they have a new look and a new feel, which I think is people like. I think it's a nice throwback and a difference from your typical Call of Duty, Doom kind of things.
Oh, absolutely. Like I just finished this game Katana Zero, just yesterday, and it totally feels like something I would have played in the 90s. But if I go back and for example, I recently modded my Nintendo 64 to support HDMI with a custom chip called an Ultra HDMI. And when you go back and actually see the way it was in the early 90s, it wasn't like it was today. These modern pixel games are extremely sophisticated. I think we've improved things where our memories have upscaled the graphics to be much nicer than they actually were.
Yeah, that's definitely an effect. I mean, we were, for our regular business here, we do game ports, and we're currently working on a port of a game from 20 years ago that ran on the PlayStation 1 and PlayStation 2. And, bringing those to a modern console and up-resing the graphics and stuff. But it's difficult. A lot of people, it's hard, even though we're up-resing the graphics, it's hard, I think, for some people to realize how much we're up-resing them because their mind makes up the differences. It's very hard for somebody to realize how low fidelity some of these games were back then. You really have to see it side by side to really go like, wow, there's a big improvement here over what it was. And it's kind of amazing that how much games have advanced in the last 20 years.
320 by 240 it doesn't cut it anymore. Indeed.
Yeah, not quite. Even though I think it's Towerfall renders at 320 by 240 internally, right, into an off-screen render target. Yeah, there's some of the classic pixel art games, C and Monogame, render to off-screen targets that are these low resolutions in order to get that pixel look, and then they upscale them and then apply a bunch of fancier effects on top of it to kind of modernize the look on top of it. So it's interesting how they do these techniques.
That is very, very interesting. Now, one of the things that, again, as a .NET, I think maybe .NET developers have a little bit of low self-esteem. Maybe I do, because like you said, we're always amazed when we find out that something like Monogame hits the big time. Is it true that Stardew Valley is written in Monogame?
Yes. I mean,
it's like the hottest game of the year. Everyone was talking about Stardew Valley, and it's everywhere. Yeah,
it's been pretty huge. Eric, the developer, he had written it like he was just a garage developer working on his own for several years, bringing Stardew Valley to market. He kind of learned programming along the way, and he wrote it in XNA back then because he liked the programming language, and he worked on it. And then we came in and started helping him a couple of years back. It was to bring it to other platforms. So at the time, it was like, well, Monogame is a perfect fit for that, since he had written in XNA originally. So that's where we started our journey of getting it to all these other console platforms. And yeah, it's amazing how big Stardew Valley is and the amount of people that play it. It's huge. It's on Switch, it's done extremely well. They just released an iOS version, which has done extremely well. I think it's still in the top 10 or 20 on the App Store. The Android version just shipped as well. It's amazing.
That's fantastic. It's so nice. And what's great about it is that you play the game and you don't know. Like, that's the way it's
Yeah.
supposed to be. Like, you just enjoy, you have a great experience, and hopefully the developer had a great experience making it and using Monogame to do it.
Yeah, absolutely. I mean, end of the day, a game is a game. It can be written in any language. Some are harder than others. Like we've been recently porting a game that was written in Java originally, and Java, as much as people think it's portable, isn't really portable. Strangely enough, so that was an interesting experiment in taking what we ended up doing with that game is we used some of the tech that we used in Monogame, and we actually took the Java code and converted it into C# using like an off-the-shelf tool that's available on the internet to convert Java to C#. And then we ran it through our cross-compiler and got it onto consoles, which is crazy that we cross-compiled it twice. But that's essentially what we did to bring it to consoles. But nobody would know. I mean, from the outside, a player would never know that it was written in Java or that it was cross-compiled twice or any of this nonsense. It's really about the developers. Picking your tools is really about the developers and your workflow. And C# is just a really nice language to work with. It's you can get to the nitty gritty if you need to. If you really need performance, you can say, hey, I'm going to start using unsafe code in this section because I know what I'm doing. And you better know what you're doing. If not, you can cause problems. Like we were porting a game the other day and it was using some unsafe code. It was crashing. We're trying to figure out why. And it's like because they were overflowing memory. They were going outside of the bounds of memory, which unsafe code in C# will let you do. It's called unsafe for a reason. But being able to turn kind of features like that on and off, is beneficial. We've definitely seen in our developing in our porting days that C++ games are generally have a tougher time being stable, and they generally are harder to get stable and reliable. You'll find more bugs and pointer errors and array errors, things that you don't generally run into in a C# based game. So there's definitely some trade-offs there. If you're not trying to make the next Crisis or the next Doom, you could probably get away with C# on just about any game that you wanted to build, and just dive into some more unsafe code practices in places where you really need crazy amounts of performance. But in general, most C# games that we ported don't use very much unsafe code. It's pretty straightforward. Because again, in these games, the GPU is doing the bulk of the work, right? You're passing it all the graphics code, all the graphics commands, and the GPU is doing the work to actually crunch out the graphics. It's mostly when your game has to have a lot of CPU intensive work that, C# can maybe become a problem. Or when you're going through massive amounts of memory, right? C# has a garbage collector, and in that, a lot of people think, well, garbage collector is bad for games, even though every Unity game has a garbage collector in it, right? But if you think of it, I always thought of it like this: like if you had a C++ based game, and every time you needed to work with a string, you'd allocate with one new and call delete on it constantly, and you'd be just making all these new and delete allocations. You wouldn't do that. You wouldn't write a C++ game that way. It's inefficient. It's a bad idea. Well, you shouldn't be doing that kind of thing in C# either. So, the same things you do in a C++ game, like pull your objects, reuse objects and pull them, is the common techniques that you would use in C#. So in general, unless you're being very sloppy, C# has never been, you can make fast games that don't get lots of GC hiccups, in C#. You just have to be a little smart about how you write it.
Mm-hmm. What is the relationship between Mono and Monogame, in the sense of Monogame runs on like most of the .NETs, right?
Yeah, it's the relationship is loose. I guess I asked Dominic Louis. He's one of the guys that took over for Jose when he was stepping away from the project, and he kind of ran the project for a lot of years. He was the one that came up with the name for changed it from XNA Touch to Monogame. And I think it just sounded like, oh well, it kind of follows Mono's naming convention, so we'll use Monogame. That's what he called it at the time. It was just that. It's never really been anything tied to Mono in any particular way, other than we use Mono on several platforms. But the relationship is loose. We really kind of follow the, try to run on whatever .NET is available kind of idea, because the truth is that every platform has different flavors of .NET. You might have an old version of .NET here or a newer one there. We experimented once with using have you ever heard of, I think it was called .NET MF, is it?
Micro framework. Yeah, it was a tiny .NET that would run on things like a NetDuino.
Right. We've experimented with trying to run on things like that. It's, I guess that's a nice thing about .NET, is that there are different flavors and you can kind of tailor it to different platforms. Now we're hoping for the grand reunification, right, where all these flavors of .NET come back together back into one thing. And maybe one day that'll occur. But till then, we're kind of maintaining our flexibility, because we know that it's just going to be different on each platform. Like we were looking at, I think Samsung uses a version of .NET on some of their TV OSs for building, where you can build games with that. And we've been looking into that platform. And it's a different version of .NET yet again. So we have to maintain flexibility, but in general, all the flavors have the same basic concepts. A garbage collector, you have the same .NET class library, which is very flexible and useful for game development. So we just end up providing our layer, which gives you the low-level graphics and your audio APIs and your input APIs, and you're ready to go. So we try to maintain kind of a conservative approach, not using the most cutting-edge .NET features unless we actually have to, in order to make sure that we can get to as many platforms as possible.
Are you trying to pound define? Pound define your way around things, or are you doing plugins to when something is specific to an operating system?
We tend to do a mixture. We do two things. We do pound define every once in a while. We did that really early on in the Monogame project. We did a lot of that, mostly because people don't realize this, but using an interface like a C# interface actually costs you cycles. Like interface function calls are slower than just a regular function call, or at least can be, especially in an AOT sense. In a JIT sense, I think the JIT can sometimes do some really clever things and optimize those things away at times. So there are some overheads to doing interface-based calls. So we've always kind of resisted doing that, just because we didn't want to add any more overhead than we absolutely had to. Especially when you're going to mobile and, every cycle kind of counts. It was really important to us not to do that. So we used a lot of pound defines early on. But that became really difficult to maintain. So the new technique that we've been using, which has actually been really, really flexible for us, and I don't think we've seen very many other projects use it, is we've been using partial classes a lot to do this. So what we would do is we would define most of the stuff is implemented as a single class that has different calls that we define as like platform calls that are platform specific calls. And those aren't implemented in the main class CS file. And then we actually have a separate CS file that's per platform that implements these other functions that are implemented through a partial function or through another function in a partial class. And that works out really nice because it kind of organizes the code in different platforms and doesn't require a bunch of if-defs, which are easily get tangled up. And, it's hard to kind of read your code if you have a ton of if-defs. But at the same time, it implies no performance cost at all, right? Because it's all done at compile time. So we've been really happy with that technique, and it's worked really well for us. So yeah, we've had pressure in the past to like make a bunch of interfaces and stuff. We've kind of held back just because we just don't want to introduce any more overhead to that process if possible. And the partial class stuff has worked really well.
Mm-hmm. So people can check out Monogame at monogame.net. There's thousands of games that have shipped with Monogame. It's supported basically everywhere: Xbox, Switch, PlayStation 4, Vita, Mac, Linux, iOS, Android, Windows. Is this a place where people could get involved if they're looking to get involved in open source? Can they maybe help you with your documentation?
Oh, absolutely. We're always looking for people to help. It's if anybody's run an open source project, they know that it's very difficult to get help and get good help. A lot of times people tend to help, but, they just don't have enough experience to help properly. So it's always difficult to find the right, good help. But anybody that wants to come in and help, jump in there. We have issues marked in our GitHub that are marked kind of good for beginner kind of issues that, anybody can jump in there and help and fix. And it's really community driven. We have a small group of kind of guys that help maintain it, from day to day, checking pull requests and things like that. But, it's pretty much all volunteer work, people that are jumping in there to help because they feel like they really want to move the project forward because they have their own vested interest in seeing the project succeed. So it's all really a volunteer labor of love from all of us.
Well, I'm looking right now and I see 16 open issues, all marked as good first issue. Great opportunity to get involved in open source. And if you're looking to make a game, do it. Check it out, monogame.net. Thank you so much, Tom Spilman, for chatting with me today.
Thanks, Scott. It's great.
This has been another episode of Hansel Minutes, and we'll see you again next week.